Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on the last part of a three-part video series on trigonometric functions for mathematics grade 10, and that is the tangent graph. In part 1, we focused on the sine graph, and in part 2, we focused on the cosine graph. And in this part, the last one, which is part 3, we're going to focus exclusively on the tangent graph. On that note, please don't forget to click the subscribe button and hit the notification bell so you don't miss out on new videos we upload in the future. And if you have a question or would like to make a video request, please comment down below with the topic and grade you'd like me to cover, or alternatively send all that information to the contact details provided in the description box. Now back to the video. In detail, we're going to look at number 1, functions of the form y equals to tan theta, which is the most standard basic equation of a tangent graph you will ever plot. Number 2, we're going to look at functions of the form y equals to a tan theta plus q. And we're going to look at the effect of q and a and how that affects how the graph is shifted across the axis. Number 3, we're going to look at characteristics, your domain, range, asymptotes, very important, intercepts, and so on and so forth. Those are your characteristics. Number 4, we're going to look at example 1. And this example, we're going to show how to sketch a tangent graph. Number 5, we're going to look at example 2. And in that, we're going to show you how you figure out what the characteristics of any type of graph that has got the standard format y equals to a tan theta plus q can be found. And by characteristics, we mean your domain, your range, your asymptotes, and your intercepts. Number 6, we're going to look at example 3, which will show you how you find the equation in case you have a function of a tangent graph drawn on a piece of paper and they say find the equation. Number 7, we're going to look at example 4, and that will showcase how you interpret tangent graphs of all types of forms. We have a lot to cover, so let's start. Firstly, let's start with functions of the form y equals to a tan theta. This is the most standard form of a graph, the most basic, and we're going to plot this between 0 and 360 degrees. That is our domain for now. And then our function is tan of theta. So you take out a calculator and make sure your calculator is in degrees, DEG. Not radians or gradients, which is RAD or GRAD. You will get the correct answer, but in the wrong context. We're dealing with degrees, not gradients or radians, so make sure your calculator is in degrees. So now you go tan of theta. Our theta is 0, so you go tan of 0, close bracket, equals to, and that will give you 0, and that's how we find that. Same thing with 15 degrees. You go tan of 15 degrees, tan of 15, and that is equals to, and will give you 2 minus square root of 3, which when you press the S to D button will give you 0.2679 blah blah blah, and which when you round off correct to 2 decimals gives you 0.27. Same thing we'll do with all those figures. 30 degrees will give you that 0.58, and notice at 45 degrees, your tan of 45 degrees will give you 1. Also notice another one, at 90 degrees, you will get a math error. Your function is undefined at 90 degrees. Take out a calculator, let's go tan of 90 degrees so that you can see exactly what I'm talking about. And that gives you math error. That means it is undefined at 90 degrees. Now, why is that the case? Before we figure out why that is the case, let's look at another point on the whole domain between 0 and 360 degrees, where your tan of that angle is undefined. Here it is 270 degrees. Well, let me show you why that is the case. Remember your tangent function, tan of theta. The tangent of theta can be written as the sine of theta over the cos of theta. This is what we call the quotient identity. Now, at 90 degrees, all right, then you have your tan of 90 degrees equals to sine of 90 degrees divided by cos of 90 degrees. Take out a calculator. Sine of 90 degrees gives you, okay, sine of 90 degrees, that gives you 1. So that is equals to 1 over cos of 90 degrees. Cos of 90 degrees gives you 0. Now you're dividing by a 0, which makes the whole expression undefined, and that's why it's undefined. Same thing at 270 degrees. Cos of 270 degrees is equals to 0, which then makes your tangent undefined because of that part. And that's how you figure out where your asymptotes are. We're going to talk more about asymptotes, but that's how you figure out where your asymptotes are. So for your normal tan of theta graph, your asymptotes are at 90 degrees and 270 degrees. And like I said, we're going to talk more about those asymptotes in the next few minutes. All right, but also notice something. So I set out a table. I created a table so that you can see how these numbers basically are duplicating each other. Let's look at the first row. The first row is pretty standard. You've got your positive values with undefined at 90 degrees. Now notice what happens here. What happens on the second part of the table is that your numbers are basically repeating but on the negative. So you got a negative 373.73, which matches what you had at 75 degrees. Same with 60 degrees matched with that, but on the negative. 45 matches with 135, but on the negative, and so on and so forth. And then you have a 0 at 180 degrees. In fact, you have 2 points, 3 points in total, where you have your tan of theta equals to 0, and that is at 0 degrees, 180 degrees, and at 360 degrees. And as you will see, that's where your x-intercepts will be. And notice that now, you're now going back. Notice that at 15 degrees, that matches with what you have at 195 degrees. 0.27 on both of them. Same with 30 and 270, 210, 45 and 225. Now, if you take 225 and subtract 45 degrees, you'll see something very interesting. 225 minus 45, that is equals to 180 degrees. Notice that every 180 degrees, you basically duplicate that point. So not only are your x-intercepts 180 degrees apart, your other milestones are also 180 degrees apart. 45 and 225 both have 1 as your y coordinate of that point. Same with 135 and 315. They are both 180 degrees apart, so they're both at -1. So that's how basically you will see how your tangent graph is duplicated. Now let's plot these points. All right, remember at 0 degrees, we're at 0, so let's plot that. At 0 degrees, we have 0. Also, another 0 is at, another 0 is at 180 degrees. I just want to duplicate all the points. And then another one is at 360 degrees. We are done with the zeros. Now, let's plot 15, which is 0.27, and one that is 180 away from 15 degrees, and that is 195. So that is at 0.27. Okay, 0.27, 15 degrees, 0.27, 15 degrees, 15 degrees, 0.27. So that's 0.5, because that is 1, that's half, 0.5. And that is 0.25, which is a quarter. Now, at 15 degrees, that's supposed to be 0.27. That means it's just above the quarter. But we must also duplicate that 180 degrees away. That is at 195. So let's duplicate that point. There. Okay, done. Now, next, we've got our 30 degrees. That is at 0.58. 180 degrees away, that's 210. 0.58. 30 degrees, 0.58. 0.5 is over here. 0.58 is just above that. So 0.58, that's where we have there. All right, but we must also duplicate that on the other side. 180 degrees away. So we duplicate that. So we duplicate that. All right, next. 45 degrees duplicates with 225. So it's at 1. 45 degrees at 1. And then 180 degrees away from 45. We also have another one there. Okay, next. We have 60 degrees. And that gives us 1.73. 1.73, that's 1.5, so 1.5 75 is there, 3/4, so 1,73 is just below that point. Right, that's okay. Let's duplicate that point on the other side, 180 degrees away. There. All right. Next, at 75 degrees, we've got 3,73. 3,7375, 3,73, that's out of range. Same thing with 255, it will be out of range. Okay. Now what we do is we now start with the ones that are less than 180 degrees. So we're going to now, okay, look at 105 all the way to 180 degrees. At 105, we had negative 3,73. Notice that it matches with 75. So 75 matches with 105, but on the negative, they are both out of range for this particular purpose. And then now, notice that 60 degrees will match with 120, but on the negative side. So for 60 degrees, we had 1,73. Notice that 120 degrees will have that at negative 1,73. So we match 1,73, negative 1,73 will be what at 120, negative 1,73. So that's 1,75, 1,73. There it is. Negative 1,73, that's just below the, there we go. And now that's for 120, sorry. Okay. Put that on the wrong place. Okay. Now notice that 135 matches with our 45, but on the negative. So it will be negative 1. Negative 1. Also notice that 150 matches with 30 on the negative. So 30 was what? 30 degrees was 0,58. So this one, 150 will be negative 1,58. Negative 1,58. 1,58. Okay, so that's negative 1,58. Negative 0, so negative 0,58. So the 0,5, 0,58, that's what? Just below the half. Alright. And now we've got, okay, at 165, the 165 matches with 15 in this case, but on the negative side. So at 15 degrees, we had 0,727. Then at this one, 165, we have negative 0,27. 0,25 is there. 0,27, that's just below that. Negative 0,27. There we go. Same thing with duplicate. We duplicate 345 is duplicated with 165. So we match there that point. So it should be matched that way. 180 degrees away. 330 matches with 150. All right, so we must have this point right there, and that's how you duplicate. 315 matches with 135. Okay, so it will be on the negative there. 1. Same thing. 300 matches with 120 on the negative 120. So there it is over there. So that's the part. Okay, next, our 285 matches with our 105, which is out of range, so it's going to be out of range over here. And over here, we don't have anything beyond 360 degrees, so that's where it ends. And now we join the points. Another easy way, effective way of finding out exactly what the points are is to use a calculator. Use a calculator so it's easier for you to figure out where to draw the lines. Now that is the graph of y equals to tan theta. Alright, here are the milestones 0, 0, or 0, 180, and 360. Those are your x-intercept. Your y-intercept is at 0, 0, the origin, and then you've got your asymptotes at 90 degrees and 270 degrees. Why? Because that's where your tan is undefined. Reason being that your cos, which you divide the sine by in order to get tan of theta, is equal to 0 in both occasions. And this is what the graph calculator calculated. It's exactly the same. Let's go back. Exactly the same. Perfect. Now, let's look at some of the characteristics. Remember your domain here. We restricted our domain to between 0 and 360 degrees. But notice something. Not everything within that domain is defined. At 90 degrees and 270 degrees, your domain is not defined. So we go. Domain is for theta between 0 and 360, including the ends, 0 and 360 degrees, but not including 90 degrees and 270 degrees. Your range, your defined, the values of y where your function is defined, there is no restriction. It goes all the way from negative infinity to positive infinity, including 0, right in the middle. So that your range is f of theta, maps f of theta is an element of real numbers. Your asymptotes, that's where your domain is undefined. They are at 90 degrees and 270 degrees. They are the blue lines. Then your y-intercept is at the origin, your x-intercept at 0 degrees and 0, 180 degrees and 0, and 360 degrees and 0. And the period, very important. The period for the tangent graph is 180 degrees. Reason being that it takes 180 degrees for a complete cycle to be fulfilled. Now you are able to see that very well between 90 degrees and 270 degrees in this instance. However, if you were to take this piece on the last bit and then take it and match it to this part, you will get another complete graph. Let me show you what I'm talking about. You will get another complete if you were to match them. So they do match each other. Now let's look at functions of the form y equals to a tan theta plus q. Now let's look at the effect of q. We know that for your basic y equals to tan theta, it's not shifted. We know that q shifts every function to the top, either top or bottom. So your q will shift your function either up or down depending on whether your q is positive or negative. If your q is positive, it will shift it up. If q is negative, the function will be shifted down by q units. So for example, if your q is equals to 2, your graph will be shifted 2 units up. So basically what happens is that the x-axis sort of like moves 2 units up. Now I'll show you exactly what I mean. So there are your 2 units. So those are your 2 units up. Let's make it black so you can see exactly what I'm talking about. And once you do that, you shift your frame of reference or point of reference, the rest bit. It makes it easier for you to duplicate that without struggling, because look at now. At your 0 degrees, you've got that reaching, it touches the point of the line of reference, which is q equals to 2. All right. Where you were supposed to have your x-intercept over there, it's the same point but 2 units up. Where you were supposed to have your asymptote does not change, it's exactly the same. Okay, but look at how your intercepts now change. Your y-intercept has been shifted 2 units up, so it will be y equals to 2. All right, 0 degrees and 2. All right, and then your x-intercept. Notice that your x-intercept has now been shifted. So you still have 2 x-intercepts, but on totally different planes. Remember, when you try to find the x-intercepts in a shifted graph. Just make y 0 and solve. That works all the time with all types of equations. Same thing with when you want to find the y-intercept, just make theta 0 or x 0 and then you solve. So that's how Q affects the function. It shifts the graph either up or down. Let's say when your y equals to 10, theta of -1, you're shifting the graph down 1 unit. Okay, let's draw a blue line of reference there. So you see, basically everything is duplicated. All right. So the blue line of reference, okay, let me fix that. The blue line of reference is not exactly where it's supposed to be. All right. Okay, there is the blue line of reference. Notice that now you basically maintain the whole thing. Now where your 0 is supposed to be 0, and then where you were supposed to have your x-intercept there, it's 180 degrees. Where you would normally have another x-intercept there. So that just duplicates, but it makes it easy for you to shift the graph down with a better focus that way. Now let's look at the effect of A. Basically, A affects the shape, whether you're dealing with algebraic expressions, functions, or you're dealing with trigonometric functions. How does it affect it? Now, look, when your A is positive, you've got your graph normally, okay, going from 0 all the way up in a sort of like back to front type of S shape. There is your red graph. There, back to front S shape. And then it ends there. It starts with this one at the top, ends with the one piece at the bottom. Now, what happens when your A is now negative? In other words, for this case, -1. If the A is -1, you still get everything exactly the same way it was. However, your graph now is reflected about the y-axis, and that is like almost like about the y-axis. So it changes its shape. Instead of going the back to front S, it now takes a normal shape of X. There is the blue graph. There is the blue graph. So we start with 1 at the bottom and with 1 at the top. All right. Now what happens when your A is multiplied by 2, for example, and you've got 2 tan theta? That's what the green graph gets you. So now let's compare the red graph y equals to tan theta and the green graph y equals to 2 times tan theta. Here all that happens is that your milestones are reached twice as fast. For example, where you were supposed to have your, your y equals to 1, for example, there at 45 degrees, it will be at 2. There. So at 45 degrees, you're supposed to have 1, but in this case, it will be at 2. All right. So you multiply your y value by 2. So as a result, your milestones are reached far much quicker. So the shape is still exactly the same, but then the graph is sort of like thinner because it reaches milestones quicker. Okay. Now let's look at characteristics of the functions of the form y equals to a tan theta plus q. Your period is still 180 degrees. It takes 180 degrees for the tangent graph to reach all the milestones, go from beginning to completion within 180 degrees. Remember, it also includes your asymptotes on either side. The domain will be between 0 and 360 degrees, right? However, you have the points 90 degrees and 270 degrees where you have your asymptotes not defined in the domain. So that excludes those 2 points. The range is all elements of real numbers. There is no restriction on the range. Asymptotes are always at 90 degrees and 270 degrees. But be careful. Be cognizant of that. Y-intercept, you make x 0 or theta 0 and solve. X-intercept, make y 0 and solve. Easy peasy, like with all other types of functions. Now let's look at the first example where basically we will look at how you plot the graph of y equals to a tan theta plus q. In this case, our a is 2 and our q is 1. How do we go about it? In our domain is between 0 and 360 degrees. We know, number one, that our asymptotes are going to be, let me change to my provocateur. Our asymptotes are still going to be at 90 degrees and 270 degrees. So here our asymptotes. Okay, let's look at asymptotes. Asymptotes will be at 90 degrees and 270 degrees. Now let's look at what the y-intercept is going to be, because obviously this one will be shifted 2 units up and it will be thinner by 2, because now you're multiplying everything by 2, you're 10 by 2, meaning that your milestones are reaching faster. So it will be thinner than the ordinary y equals to tan theta, and it will still be shifted 1 unit up. That's what the Q is for. So now let's look at the y-intercept. Now that it's going to be shifted, let's look at the y-intercept. Make theta 0. Okay. Now, therefore, y equals to 2 tan 0 degrees plus 1, which is equals to, take out a calculator and you go to tan 0 plus 1, and that will give you 1. That's your y-intercept. So the y-intercept, the point there is 0 degrees, 1. All right. Okay, now let's look at the x-intercept. You make y0. Make y0. Okay, when we make y0, 0 equals to what? 2 tan theta plus 1. Now take everything that is not theta to the left hand side, so you got -1 equals to 2 times tan theta. Divide both sides by 2, so you have -1 over 2 equals to tan theta. And now let's find the angle theta. Therefore, 10 to the -1 of -1 over 2. That's how you find theta equals to theta. Take out a calculator and you go shift 10 bracket negative, and then the common fraction button, 1 at the top, downward arrow 2 at the bottom, right arrow, and then close brackets. That will give you -26,565, and so on and so forth. So therefore, -26,565, and so on and so on and so on. That will be equals to theta. That's in degrees, meaning that, okay, if we let's round this off correct to 1 decimal. That will be therefore -26,6 degrees. That will be our first point where our theta touches the x-axis. So now how do we figure out between this domain of 0 and 360 degrees? How do we figure out where the first one becomes? Remember, all the milestones are 180 degrees apart. So what you do is you add 182 this to -26,6. So you go the theta 1 and theta 2. This is the first point where you will hit your x-intercept. So that will be -1, so -26,6 plus 180 degrees, and that gives us the point. Okay, let's see. So if we add 180 degrees, that gives us the point 153,43. 153,43. 153,43. All right. Next one, you add 180 degrees to that. 153,43. So next one is 153,43 plus 180, and that should give you what? So you just go plus 180, and that will give you 333, 333, 43, 43. Sorry about that. 333.43. And that is your x-intercept. So you've got your y-intercept at the point 0, 1, and then your x-intercepts are at 153.43 and 333.43. These are important milestones, and we need to plot them on the graph before we plot the normal graph. Okay, so now let's plot those points. Okay, the first x-intercept is at 153.43, so that's about somewhere here. Let's see, that's about somewhere here, 153. That should be somewhere there. It's 100 and yeah, that should be somewhere there, just there. Okay, the next one, 333, that should be somewhere there. 333, that should be somewhere there. 180 degrees apart. All right. Now what we do is we plot the normal graph of y equals to tan theta. Take out your calculator. Take out your calculator. So we go at 0 degrees, that's 0. At 45, that's 1. Okay, same thing with, okay, 180 degrees at 0, 360 degrees at 0. All right, and then when we want to duplicate this point at 45, that's 2251. Okay, all right, now this one, 45, is duplicated with 45 is duplicated with 135 or -1 there. Okay, same with this one, 315 and -1. Okay, the other ones are, okay, 10 or 15 degrees. Take out a calculator, 10 or 15 degrees, just to make sure you've got those right. Okay, that's 0.27, 0.27, 0.5, 0.25, 0.27. That should be somewhere in between there. All right. Same thing, same is duplicated over at 195. Okay, 195. So that should be somewhere there. All right. Okay, 30 degrees, 10 of 30 degrees, 10 of 30 degrees. We want to duplicate those points quickly. 10 of 30 degrees, that is 0.58. 30 degrees, 0.58, that's 0.5, so that's just about there. Okay, let's duplicate that point over here on the right hand side, so it will be at 230 degrees. Yes, 230 degrees. Duplicate that, that's just over. Okay, good. All right, now at 60 degrees, 10 of 60 degrees, that is equals to square root of 3, which is 1.73, 1.73, 1.73, so that's 1.5, 1.75, 1.73 is right there. All right, we duplicate that on 240. All right, there we go. Now 255 and 75 are duplicated the same way. 10 of 75, 10 of 75, let's see if we get. That is 3.73, 3.73, 3.73 is almost there. Almost there. So let's duplicate this on the right hand side. That's a 255. There is the duplicated point. All right, on the left hand side to the left, what we do is at 165, 165, 10 of 165, 10 of 165, which is over here, 10 of 165, that is equals to negative 0.27, negative 0.27. So it matches with 15, but on the left side of y, on the negative y, Okay, so 165, that's okay. Good. So that's there. Okay. And then we are matching, sorry. And then we are matching okay, the negative 1 matches with 135, sorry about that. Negative 1 matches 1. And then the 30 degrees matches with 150. 30 degrees matches with 150, so it should be just over there, less than 1, but just over a half. Less than 1 by just over a half. There it should be. Alright, there we go. And then the next one that we need to duplicate is 120. It goes with 60, so that's a bit just almost at 2, so just almost at negative 2 right there. And then the last one is 105, which matches with 75. That should be at negative just over 3,5, but below 4. Negative 3,5, but below 4, somewhere there. Should be somewhere there. And now okay, same points we duplicate on the other side. Okay, 0, 3, 4, 5 matches with 165. And then we've got the next one is 150 matches with 330. The next one is, okay, 120 matches with 300. So we've got it over here. That's where you need to be. Okay, next one, 265, or is it 295 matches with 105. And there we go. Okay, now let's join the points. All right. Okay, let me fix that. All right. Now we join these other ones. All right. And then we join the last bit of the y equals to 10 feet. Now we draw the graph of y equals to 2 tan theta plus 1. Same thing we do. Now all we do is basically on the what was supposed to be your x-intercept. Instead of it being at 0, it is shifted 1 unit up, so that becomes, okay, so let's take it back to the color. Okay, but it's okay, let's use this color, that's fine. All right. So that's 1, or you can take out your calculator and go to tan theta plus 1, which we've already done because that's what the y-intercept is. All right, next, do the same thing at 15 degrees. That gives you 1,53. So that's 1,53 at 15 degrees, 1,53, 1,5. It's somewhere there. 1,53 is just a bit above that. All right. Now, next thing for 30 degrees, same thing. 30. That gives you 2,154. So that's over 2,154. So that should be somewhere there. All right. Next, you go 45. Okay, 2, 10, 45 plus 1. And that should give you 3. So you just shifted that 2 units up. At 60 degrees, same thing. And watch us duplicate these points so you don't have to work everything out. one by one. 4,46, that's almost 4.5. 4.5, but just below that. Okay, there we go. Next, the last one is 75. 210 of 75 plus 1. 75. Okay, and that gives us 8,46, so that's almost 8,5, and that's out of range. Same thing, let's duplicate this point over here, so that will be 1. It will be up there. This point will be up there. Okay, same thing with at 360 degrees, it will be at 1. Alright, now let's duplicate the points. 15 goes with 195, so we should take it here. Okay, there is the duplicated point. 195. Alright, 195. Next, 230, 210 matches with 30 degrees, and this is where it is. Oh, sorry, just over 2, just over 2. Okay, there we go, just over 2. Next, 225 matches with 45. It should be at 3. 225 should be at 3. Next, 60 matches with 240. It should be just below 4. Just below 4 there. Alright, next, 75 matches with 225, and that's out of range. Now to the left, at 165. At 165, okay, we go 210 of 165. 165. So that is equals to 0,46. It's almost 0,5. They're almost half. They're just below half. Alright, just below half. There we go. Alright, next, we have at the 153, and then at 150. Okay, let's see what 150 gives us. 150 gives us the point negative 0,154, so just negative 0,154, so that's just under that. Okay, there. Alright. Next, at 135, let's see. 135. Okay, that gives us negative 1. So at 135, it's exactly meeting with the other graph, the graph of tan theta. And then at 120, okay, let's take it 120. That is equals to negative 2,46. So it's like just above negative 2.5. Negative 2.5, which is just there. So that's just still above negative 2.5. And then the last one, which is 105. 105 is at negative 6,5. Negative 6,5. That's outside of the range. So let's duplicate this point. Okay, at 180 degrees, that matches with 360. Okay, now 345 matches with 165. 345 matches with 165, so it should be there. Alright, and then the next one should be there. Next point should be there. At let's see, 330. Okay, next point should be at 330. The 330 matches with that one. Okay, it should be there, down below. Okay, so this point should be here, 333. Yes, 333, that's the point. And then this one should be matching with that one, the 330. They will should have that. And then at 315 matches with 135, they're exactly the same. They meet there. And then 300 matches with 120. So it should be down there. Okay, and then the other one is out of range. Alright, now let's match the two. Let's connect the dots. Okay. Here is where the graph meets the. Alright. Here is where the graph meets. The graphs meet at 135. Okay, over here. And that is how the graph of y equals to 2 tan theta plus 1 is supposed to be like. Now let's look at what the graph calculator. Okay, they meet at 315 and 135. Let's see if we got that right. 135 and 315 at -1, both of them. Perfect. Now the shape also goes accordingly. Now let's look at the next example. Example 2, state the coordinates of E. They're the coordinates of E and the domain and range of the function in the interval shown. Okay, let's start with the coordinates of E. The x coordinate is 180 and the y coordinate is 1. So here is what we have. Okay, let's change the color. Alright, E, the coordinates of E, or theta y, E theta y equals to E 180 degrees, and then the y coordinate is 1. 180 degrees, and the y coordinate is 1. The y coordinate is 1. Yes, those are the coordinates of E. Now, as for the domain is between 0 and 360 degrees, but not including 90 degrees and 270 degrees, because those are your asymptotes. Okay, so the domain is such that theta is between and including 360 and 0 degrees, but not including, theta is not equal to 90 degrees and it's not equal to 270 degrees. That's the domain. The range is very simple. Range your y f of theta maps f of theta is an element of real numbers. That's your domain. That's your range. Question number 3, example number 3 says, given the general equation y equals to a tan theta plus q, find the equation of the function. All right, there we go. So here we given a function, a graph that we need to find the equation of. So we've got 2 points in the graph, and we know that the general equation is y equals to a tan theta plus q. We're given 2 points, 135 -1 and 180 -2. This is another case where you need to use your knowledge of simultaneous equations. So here is the point, y equals to, sorry, So let's fix that. Y equals to a tan theta plus q. Our point. So the first point that falls on the graph is 135 negative 1. Point 135 negative 1 lies on graph. Lies on graph. Lies on y. Therefore, now what you do is you substitute this point, negative 1, into the equation. A tan of 135 plus q. Therefore, that is equals to negative 1 equals to a. What is 10 of 135? Take out a calculator and you go 10 of 135. 10 of 135 equals to negative 1. So that gives you negative 1 there plus q. Therefore, negative 1 equals to negative a plus q. And that's your first equation. That's the equation 1. Okay, another point. Here's the second point. Point 180 negative 2. Point 180 negative 2 also lies on F, on Y. Okay, therefore, we substitute that. Negative 2 equals to a tan of the angle is 180 It's 180. That is negative 2. Sorry, the 10 of 180 plus q. Sorry about that. Plus q. And therefore, negative 2 equals to a tan of 180 degrees. Tan of 180 degrees. That is equals to 0. So that is 0 plus q, meaning that therefore negative 2 equals to q. That is your second equation. From 2, okay, q equals to negative 2. Now you substitute this into equation 1. Substitute into 1. Okay, what do you get? Okay, if you substitute that into 1, you got negative 1 minus a plus negative 2. You get therefore negative 1 equals to negative a plus, here is 1. Negative 1 equals to negative a plus, q is negative 2, so you substitute that one. So negative 2. Therefore, okay, take everything to the left hand side that is not a. So we have negative 1 plus 2 equals to negative a, sorry, negative a. Therefore, 1 equals to negative a. Therefore, a equals to negative 1. Meaning that therefore, the equation is y equals to a is negative 1, negative tan theta, and then q is 2, negative 2. Negative, yes. A is negative 1, so that is equals to y equals to negative tan theta minus 2. And that is the equation. Next and last example, example number 4. The diagram shows the graph of f of theta equals to 3 sine theta and g of theta equals to negative tan theta. Minus 3 sine theta, this is the 1. 3 sine theta, this is the 1. Get me. This is 3 sine theta, the black one. And then the blue one is negative tan theta. The blue one, which is the 10, it's negative tan theta. And the question says, give the domain of G. Okay, the G is your tan theta. The domain of G is very easy. You go from 0 to 360 degrees. but they are asymptotes at 90 degrees and 270 degrees. Okay, A. Domain of G okay, your theta is between 360 degrees and including and 0 degrees, but not including 90 degrees and 270 degrees, because that's where your asymptotes are. Okay, number B. The question goes, what is the amplitude of F? Amplitude of F, remember amplitude of your sine and cosine graph, that is your maximum point from the point of rest to the maximum point or the point of rest or the negative or minimum turning point, or simply what your A is. A equals to 3, and that is what your amplitude is going to be. Okay, A equals to 3 here, therefore amplitude, your amplitude equals to A equals to 3. Absolute value of A, which is equals to absolute value of 3, which is equals to 3. Number C. Determine for which values of theta your f of theta equals to 0 and your g of theta is equals to 0. Where these two graphs are 0. Where are these two graphs are 0? Okay, they are both 0 at 0 degrees, and they are also both 0 at 180 degrees. Another point where they are 0 is 360 degrees. So f of g okay, f of theta equals to 0 equals to g of theta when theta equals to 0 degrees. Another one is 180 degrees, and the last one is 360 degrees. All right, number D. Okay, let's see. No, that's C2. That was C1. C1. That was C1. Okay. This is C2. Let's fix that. C2. All right, and the question says, determine for which value of S the product of the two graphs is negative. Now, you will have a negative when you multiply a positive by a negative or a negative by a positive. In other words, one of the graphs needs to be above x-axis and one needs to be below x-axis for the product of the two to be negative. All right. So where F here is above the x-axis and G is below the x-axis. So this is negative and that is positive. So between 0 and 90 degrees, but not including 90 degrees, it will be, okay. Where it's negative, not equal to 0, so it's between 0 and 90 degrees and not including any of them. So the first bit is that. The second bit is between 180 degrees. No, they are both negative here, so the product of the two will be positive. Here they are both positive, so the product of the two will be positive. Here is where they are negative. Okay, one is negative and the other is positive. So that is between 0 and 90 degrees and 270 degrees and 360 degrees. That's when. Okay, f of g, f of theta times g of theta is less than 0 when theta, okay, theta is between and not including 90 degrees and 0. And theta is between and not including 270 and 360. 270 and 360. 270 and 360. Okay, let's see. 270 and 360. All right, now number 3. Number 3 goes, where is the ratio of the two positive greater than 0? Okay, g of theta will be divided by f of theta will be positive if they're both either positive, right? Or they're both negative. That's when it will be. Okay, when are they both positive and both negative? They're both positive here between 0 and 180 degrees, and they're both positive between 180 and 270. So that is the interval between 90 degrees and 270 degrees, not including. All right, so that is, let's add another. Okay, so that is number 3. Number 3. F of theta divided by g of theta will be positive when theta is between, not including, okay, let's go back to that, when theta is between 90 degrees and 270 degrees. When theta is between 270 and 90, not including the. Now let's go to the last question. Determine the values for which values of theta f of theta is increasing. F of theta is the sine graph. Where is it increasing? When you look at from left to right, it's increasing between 0 and 90 degrees, and it is also increasing between 270 and 360 degrees. So it's between 0 and 90 degrees. Okay, f of theta is increasing when theta is between 0 and 90 degrees. Okay, let's see. When theta is between 0 and 90 degrees, and when it is between 270 and 360 degrees, it's also increasing. And when theta is between 270 and 360 degrees, let's just confirm that. Correct. And that is how you interpret the graphs. Now we've come to the end of this video. Thank you for watching, and see you on the next one. Bye.